go. Thank you all for joining me. This is going to be DevOps 101, a history of package management. Because this is a 101, I'm not going to go into like super deep technical detail on any one particular subject. I don't find that that's typically helpful for a 101. If you have super deep technical questions, I'll be happy to try to answer them. But if it goes like too far into the weeds, I will say, this is a conversation we should have privately. Please email me, because I don't want to create confusion for any newbies that are listening. So here we go. First, I'll introduce myself. My name is Kat Cosgrove. That cat is Espresso. You will probably hear her at some point. She really, really does not like being left out of the action, and I'm a developer advocate at JFrog. Before that, I was an engineer also at JFrog on the IoT team. However, I didn't get where I am through like strictly traditional means. I was a freelance web developer for a while, but I have also worked as a bartender and a waitress and a teacher and the resident horror expert at an independent video store. So if you would like to ask me questions about horror movies, that's fine too. I did go to college, but I didn't go to college for computer science, and also I dropped out. The only formal education I ever completed really was graduating from Code Fellows, which is a coding boot camp in Seattle. And I was hired fresh out of Code Fellows at JFrog. So I was suddenly put into a very fast-paced environment where I needed to quickly become functional in quite a lot of different tools and technologies and workflows that I had never been exposed to. Because my time as a freelance web developer, I was all like community taught, self-taught, and so I didn't really know what I was doing in some ways. And I credit a lot of my success as an engineer and as a developer advocate to the fact that I didn't get here in the like traditionally prescribed way of becoming an engineer. It let me see the tech industry from a lot of different angles and have a lot of different struggles that it turns out are fairly universal regardless of where you came from. Like the fact that somebody has a computer science degree isn't necessarily going to prevent them from having some of the same problems I had. And we aren't really addressing these problems. So I would like to address that problem. One of the biggest issues, I think, is not giving new people context and history for the tools we use. We don't understand why. We aren't ever taught or explicitly told why this thing is useful and like what pain point caused us to be using this tool now. So you can just use it. You don't need that to be functional, but it helps and it makes it easier to adopt those tools. So that's the point of this series of talks, to try to eliminate that. If you would like to get a hold of me later, you can do that. You can find me on Twitter at Dixie3Flatline, and you can also email me at catc@jfrog.com. Though, fair warning, I'm not really great at responding to my emails. So I do respond eventually. It just takes me longer than it takes me to respond to like a Twitter DM. If you have questions while I'm talking, please put them in the Q&A box, not in the chat box. The chat box is a little bit busy right now, and it's hard for me to keep an eye on it, but I will see the like notification come up for the Q&A. If I can answer it while I'm talking, I will do that. If not, I will save it to the end. So here we go. Oops. So when you're new to an industry and you're encountering a lot of new concepts, it can make it really difficult to get your feet underneath you. It's an unfamiliar landscape. We have quite a lot of jargon. And even though DevOps has been a thing since, I think most people credit the beginning of DevOps to the first DevOps days in Ghent, which was 11 years ago, people still disagree about what DevOps means. Is it a methodology? Is it a tool set? Is it a culture? Is it just a buzzword? And a lot of the documentation out there assumes that you already have some additional context and experience, or you're already proficient in some related tooling, like a precursor to the thing that you're trying to use. And the amount of jargon we have is outrageous. There's abbreviations and abstractions abound, and sometimes it's hard to define a term satisfactorily without using two more pieces of jargon that you also have to define. And we're missing all of this historical context. So I want to give you some of that context. And on the subject of jargon, if I use a word that you're not familiar with, please also put that in the Q&A box and I will define it for you, or at least define it as I meant it, because some of this stuff is still kind of in flux a bit. I'm going to start by defining DevOps as what I mean in this talk. DevOps is the term for the union of the development team and the IT operations team through the use of a specific set of practices and tool chains. So rather than having the development and operations team handle their own specific responsibilities independently of one another, the two teams should work together. This is both a cultural change and a technology change, with the ultimate goal of drastically reducing the amount of time it takes the team to deliver software. Sounds good, right? So the result is more frequent software deployments, deploying bad updates less frequently, which is really what we want, and being able to recover from those bad updates faster, because no matter how good you are and no matter how good your pipeline is, you are absolutely going to deploy a bad update eventually. Accept that now. It's going to happen. One of the tools that makes this possible is a package manager. And from there on, eventually we evolved to a point where we needed a binary repository manager. Let's get in there. So in order for DevOps to work, we need both tools and a culture shift. This is an established fact, but it's still the topic of a lot of conference talks about DevOps, while more companies move away from like older methodologies and over to ours. I'm not going to go into this a ton because more qualified people than me give outstanding talks on this subject, and you should go like listen to them. But it's worth noting that it's kind of still in flux a bit. Ultimately, the goal is to merge with your source repository and pull from main often, like multiple times a day. You should be making much smaller changes every single time. Build and unit tests need to run with every single commit, and that whole thing has to be automated. And there are a bunch of tools that make this automation work. But ultimately, developers don't exist in a silo anymore, right? Everyone has to do DevOps to some degree. And this shift can take some getting used to, but you're going to be much more efficient and much less stressed out because a lot of the things you were doing manually before are going to be automated by your tools. The point I'm trying to make here is that an understanding of DevOps practices and all of the tooling that goes with it, from like CI servers to package managers, is no longer the exclusive domain of people with the word DevOps in their job title. It is everyone who touches either side of the equation, or else it doesn't work. So it's not just DevOps engineers or SREs or release managers, it's everywhere. A lot of the things we think of as being DevOps or being cloud native or whatever is pretty new in the grand scheme of things. For instance, the first commercially successful serverless platform was AWS Lambda in 2014. And now there's more of them than you can shake a stick at. It's a lot at this point. Plus some serverless databases, just like for fun, sprinkle some on there. It's kind of mind-boggling when you look at like the timeline of how we got where we are now. The technology evolves very, very fast, and we are just throwing like layers and layers of abstraction between us and our code. And as a result, more and more teams across an organization have to be familiar with these things. It happens so fast. Some of these things that feel really new, though, are actually super old, like continuous integration, for example. There's a question in the Q&A, how is it different than continuous full stack development? The two are not, full stack development is, it means building both like the front and back end of an application. If you call yourself a full stack developer, you're proficient in the front end and the back end of the development stack. Continuous, just as a modifier there, just probably means that they're engaging in continuous integration practices as a full stack developer, would be my guess. I've honestly never heard that phrase, continuous full stack development as a whole. That's my guess at what it means, though. There we go. So back to the history lesson. Continuous integration. It was first proposed way longer ago than a lot of people realize, in 1991 by a man named Grady Booch in his book, Object-Oriented Analysis and Design with Applications. So it's old. The Booch method advocated for more frequent uses of like classes and objects in programming, which simplified design. And then in 1997, we got extreme programming as a thing. It built on the Booch method by advocating for now releasing multiple times a day. Booch didn't recommend that. I know the name sounds like really, really ridiculous now. It kind of gives you like a 90s X game kind of like edgelord vibe, but that's not what it meant. It didn't actually mean to sound like edgy product marketing from the 90s. What it meant is taking concepts and paradigms that were already accepted parts of writing and releasing software, and then taking them way further to the extreme. So instead of just code review, do it constantly by pair programming. Unit and acceptance tests became a thing. And ultimately, what we wanted here was to make it easier to write clearer, higher quality code and get it to the users faster. The first open source tool for continuous integration came out in 2001, a full 20 years ago, and it was called Cruise Control. So while tools like JFrog pipelines and Circle CI might feel shiny and modern and new, the concept is actually almost as old as me. The popularity and prevalence of CI/CD changed things for the better in a pretty radical way, but I would argue that the invention of the package manager was just as important, if not more. And it happened after the invention of CI. Let's talk about what a package manager is first. From Wikipedia, a package manager or package management system is a collection of software tools that automates the process of installing, upgrading, configuring, and removing computer programs for a computer's operating system in a consistent manner. The consistency is what's key here. So if you're a developer, you've probably used one of these, like almost certainly you've used one of these. For instance, if you're writing Node.js, you're probably using NPM. That's a package manager. If you're using Linux and you've ever installed something with apt-get, that's a package manager. So in plain English, a package manager is what handles the heavy lifting involved in installing something, including that thing's dependencies, also important, validating that it is what it says it is to an extent, usually by validating checksums, keeping track of versions, upgrades, and handling the uninstall for you if you want to uninstall it. This is accomplished in part through the use of a very large amount of metadata, which is just defining characteristics about a particular package alongside the actual application binary. Modern package managers are why you can reliably run, like, I don't know, pip install Django at version 1.3.3 and be pretty sure that you are getting version 1.3.3 of Django. Or you can just run pip install Django and it'll give you whatever is the most recent stable version. We didn't always have this, though. I know it feels like we've always had this, but we haven't. The earliest versions of what you would call a package manager are actually from the mid to late 90s. So Debian introduced the first one with DPKG. Some of you will say Debian. I've heard that Debian is absolutely correct because of who the distribution was named after. But I say it both ways. It doesn't matter. So that was introduced in 1994. And then Red Hat's RPM was introduced in 1997. So continuous integration predates package managers by several years. And both of these are actually still in use today. They are much improved since then, but they are still both in use. Before those, and until package management really took off, we had to do a lot of things manually, and we had way less information about the things we were installing. It was slow, it was tedious, it was irritating, and it was very much prone to failure. So here's how it would work. You would get a compressed directory, usually in the form of like a tar file, decompress it, and you would find a README with some instructions to follow. Some kind of config script would be there, which would, when you would run it, would tell your C compiler what to do, where new binaries should go, what application dependencies to look for, and where, and on and on and on. If anything went wrong, it would exit, and you would have to go install some more dependencies. If it found everything it needed and the config script completed, it would spit out a make file. Run the make command, and if everything compiles correctly, run make install to finally install the application. If everything went smoothly, it was easy, if a little tedious. I don't like using the word easy in technical presentations, but it was the clearest way to get the point across there. It kind of, ideally, things just fell into place there. It was tedious, it was repetitive, you had to take multiple steps manually, but in theory, this was simple. It was rarely actually easy to do things that way, though. And updates were just as involved, if not more so. Obviously, this is a time-consuming process, right? Imagine having to do that for every piece of software on your computer and every piece of software required to run all of that software. Dependencies were not installed automatically like they often are now. And a lot of things could go wrong on your journey from downloading a tar file to actually getting the thing installed. Some things are still done this way. You may have done this yourself before. I've done it. It's still like fairly common in embedded Linux development, though becoming less so with the popularity of Conan as a package manager for C and C++. So understandably, everyone thought this was exhausting. Like, I think it's exhausting when I still have to do this on like an IoT device. And so the release of the first package managers for Linux was a really big deal. It was like capital A big deal. It immediately changed computing and application development for the better forever. So it was like a really pretty sunrise, right? The day was bright. Love it. But those early package managers pretty much just gave you install, update, and uninstall. They were not that smart. Over time, however, package managers have bundled all of that work and more into simpler and simpler commands. We're encoding extra information alongside the application binary and its dependencies now, like version numbers and checksums and dependency graphs, and on and on and on. As the popularity of package managers for Linux grew, so did the demand for something similar for other languages, because we didn't have them at the time. Thus, a whole series of package managers for other languages were born, from CPAN for Perl to PyPy for Python, Cargo for Rust, and on and on. Everything has a package manager now, all with the goal of making it easier to distribute and use software. This introduced a whole new problem, though. Since applications are easier to install and update and manage, we start building more complex applications. And with continuous integration becoming popular in the 90s, we start releasing more often too. Polyglot applications, meaning software made up of components written in multiple languages, become more and more common, forcing us to deal with multiple package managers for one application. Organizing and keeping track of all of these packages kind of becomes a lot of labor. We've replaced one problem with another. We start to care about security more too, with a lot of dependencies being pulled from public repositories. This is where a binary repository manager enters the playing field. Now we have another thing we have to deal with. So a binary repository manager is there to manage all of those binaries we now have into a system of repositories. Some of them support just 1 or 2 package types for very specialized applications, but the one I'm going to talk about supports 27. This is not the same thing as source control, to be clear, just to avoid confusion there. Source control is where your code lives, but this is more like an extension of it. So while your code might live in a repository on GitHub or Bitbucket or wherever, the result of that code being built or compiled, your artifacts, those should live in a binary repository manager like Artifactory. So for DevOps to really work, this is an important part of the equation. You need a tool like this. We're delivering updates far more often now, and we need a way to organize our build artifacts in a sensible way so that they're easier for our other tools, like our CI system, to interact with them and ultimately deploy those updates to our users. Without one, it is much more difficult to track version numbers, control access, promote builds from testing to production, collect metadata, or detect security problems. Try to imagine writing code and keeping it organized without tools like Git and GitHub. It sounds miserable, right? I mean, do I have some abandoned side projects that aren't versioned with Git that are just hanging out in like projects 2019 for real this time experimenting? Yes, but it's a side project, not production code, right? It's okay if I abandon my stuff like that. It's not okay to do that for your code. It's the same for binaries and a binary repository manager, especially on teams that have multiple languages in one house. It could, if you were trying to manage multiple languages in one house without something like a binary repository manager, things could be much easier than what you're currently dealing with. If you use something like this, you can store your Go, JavaScript, Docker images, Python, and Java binaries all in one tool, plus more, for a total of 27 different package types with a generic repository that you can just like cram whatever into. So Artifactory in particular works by breaking up the repositories into 3 different classes. We have local, remote, and virtual repositories. Local repositories are what they sound like. These are repositories for your packages resulting from local code that exists on your machine, your stuff. Remote repositories are also fairly self-explanatory. They contain remote build artifacts, like your project's dependencies. This one functions kind of like a cache, so that after the first download, your project pulls its dependencies from the associated remote repository rather than from the actual remote source like NPM or PyPy. If you're using Docker, this is particularly helpful since it limits the number of pulls you need to make against Docker Hub, and you won't hit the cap they set as quickly. If you are using JFrog Artifactory SaaS, you are actually exempt from Docker's rate limits, which is pretty cool. Virtual repositories are a little bit weirder. They create a kind of like envelope around the local and remote repositories for your projects. And tools like this allow you to keep your binaries, dependencies, and any build artifacts well organized, regardless of the number of languages involved. A lot of headaches are saved here from an organizational standpoint. Things get released faster because your builds are more organized in a central location, and it's easier to integrate with a CI/CD solution. And there's no jumping around between a dozen tools that all do the same thing, but for different package types, because now you're probably building a polyglot application. You're probably dealing with 2 or 3 or more package managers. And nobody wants to bounce around between all of those different package managers anymore. This improvement alone decreases the likelihood of a bad build making it out into the wild, because humans are really, really bad at repetitive tasks. We screw up a lot. We get tired, we get bored, we get distracted, and we make mistakes. This does not make a mistake. Computers don't make mistakes. They don't get bored. They don't get tired. If they make a mistake, they were instructed poorly, but they can do the same thing over and over again, and we can't, not as reliably. However, there's a very tangible benefit beyond organization that I like to use as an example to drive the point home, and that is security. I'm going to tell you about an exploit that most of you are probably familiar with, but you might not be aware of exactly what happened and how bad it was. So this is the story of the Equifax breach. In September of 2017, Equifax announced that a serious breach had occurred between May and July of that year. The first month is important. It was May. The names, addresses, birth dates, driver's license numbers, and social security numbers of just shy of 149 million Americans had been stolen. A significant portion of you watching this were probably victimized by this too. The hackers had exploited CVE 2017-5638, a vulnerability in a very commonly used web framework called Apache Struts. Talking about how that vulnerability actually worked is way out of scope for this webinar, but the gist is that it would allow an attacker to remotely execute commands with whatever authority the web server itself had. And this was not a vulnerability that flew under the radar at all. Even before the breach, this CVE was big news in the security world. It was classed as a critical vulnerability, something that absolutely had to be taken seriously and corrected immediately. Really, it was a big deal. They should have known. This vulnerability was disclosed and published in March, months before Equifax was breached. Once they discovered the breach, it took them 2 full months to find and upgrade all usages of the vulnerable version of Struts. And hackers had spent 134 days undetected in Equifax's systems. Lawsuits were filed, resulting in a $575 million settlement with FTC, as well as payments and credit monitoring for those affected. Unfortunately, the number of people affected by the breach was so large that after attorney's fees, most people got nothing but a lifetime of being paranoid about their credit. This was caused by a lack of vulnerability detection. It was also caused by a lack of an ability to update quickly and just generally not knowing what was going on inside of their builds. They didn't know what these packages had in them. The vulnerability was disclosed in March, but the breach began in May. If they'd been using a binary repository manager, if they'd been able to update quickly, if they'd had vulnerability detection in place, this might not have happened. They could have updated the affected version of Apache Struts in the 2 months between the vulnerability being publicly disclosed and when the hackers finally exploited it. Or it wouldn't have taken them a further 2 months from detection to find all of the vulnerable usages of Struts within their application and upgrade them to fix the version. So as complexity increases, which is what package managers gave us, the security concerns get larger and larger. And we need tools to keep all of these different packages organized so that we know what's going on. We have to know what's going on in these tools, or we're exposing ourselves to attack. And we don't want that, right? So package managers are a set of tools that make it easier for you to install, use, update, and remove applications. They go further than just automating the steps we used to have to take manually with config scripts and make files by also now installing your dependencies for you and managing a bunch of extra metadata that we didn't have clear access to before. Eventually, this revolution caused a rapid increase in application complexity. The next leap from there is to use something like a binary repository as an extension of our source code repositories to manage all of these binaries and build artifacts we now have being produced by our package managers. Doing so gives us more insight into what's going on with our builds, a simpler way to control who has access to what, and a place to keep all of our build artifacts regardless of the languages or tools involved in our applications. This is a boon to your developers from like just purely a sanity and organization standpoint, to your users in the form of getting you faster updates, and to your legal team in the form of faster detection of critical vulnerabilities so that you don't get sued. The invention of the package manager is possibly one of the most important innovations in computing in decades. And a binary repository manager is one of the most important parts of a functional DevOps pipeline. We have come a very, very long way from doing all of this manually and not having CI to now. It's astonishing how fast we can do things that used to be so tedious. And I think we take that for granted sometimes, how quickly and easily we can accomplish some of these things now. You know, it may not actually be easy, but compared to the way we were doing things 20 and 30 years ago, it is, or at least it's less difficult to pick it up. It's less difficult to figure out what went wrong when something failed, just because we have more information. And package managers is ultimately what gave us more information. CI may have made it easier to automate all of these things, but where would we be with figuring out what's wrong when something goes wrong? Because something will, it's not an if we didn't have package managers and all of the metadata that comes with them. If you want more DevOps, SwampUp is coming soon, and the conference days are free, like free, not free as in beer, free as in actually free. We are running it twice, May 25th to the 27th for the Americas, and June 1st through 3rd for Europe. There's also a full day of training available as an add-on for your ticket from intermediate to advanced courses. I will be speaking there, and so will a bunch of other really smart, rad people who are both smarter and radder than me. So check it out. I hope I've helped you understand what a package manager is and how we got here and what the natural extension from there is. If you're still confused, that is okay. This is kind of a big thing. And like I said in the beginning, some of it is still in flux. DevOps changes very, very, very rapidly. And even the definitions of some of these things have changed a little bit. Feel free to get in touch with me on Twitter at Dixie3Flatline if you have questions that you don't want to ask here, but I will also take some now as well. See what's in the QA box. Factory jargon. Artifactory is a universal binary repository manager. So it's a tool that allows you to deal with all of the different package types we have now. So it lets you organize everything into one tool rather than going out to like 5 or 6 different tools if you're building an application out of multiple languages. Artifactory, ARTIFACTORY, Artifactory. And what is SwampUp? SwampUp is a free DevOps conference that JFrog is putting on this year. I'll go back to the slide for that so you can see it. I'll check the chat too now. Yeah, if you check the chat, Lori is putting links in there for SwampUp and for Artifactory, if you want to actually poke around with it yourself and try to organize your binaries. And if you have questions for me, you can put them in either the chat or the Q&A box. I am now watching both because I'm not talking and reading slides anymore. What's an artifact? An artifact is anything that is the result of building your application. So it could be your actual, just your compiled binary of your application. It could be a Docker image. It could be metadata about your build, but broadly, it means anything that is the result of building your application, up to and including the actual compiled binary. You're welcome. Where does Yum DNF sit in this arena, please? Yum is a package manager as well, I think. I've never used it. Let's see here. I apologize for my keyboard. Yeah, Yum is a package manager for Red Hat Enterprise. So it's similar to things like RPM and DPKG. There are so many package managers out there these days for so many different tools. Like that's why this can get kind of complicated. Isn't it similar to Jenkins or Chef? No, not quite. So Jenkins is a CI tool. It's a CI server. So it's what allows you to automate things like building and deploying. And Chef is kind of like config management. So not quite, though both of those tools, Jenkins and Chef, will be like dealing with application packages, but they are not strictly package managers by themselves.
Okay. Do we have any additional questions for Kat? Kat, thank you so much. It was such a great talk.
You're welcome.
If not, we can start to wrap up.
How do you recommend someone that has a background in the NetOps and SecOps space transition to a DevOps role? Is being a developer a requirement? It depends on what you're doing in DevOps, so it's such a new thing. Like, I know we say, oh, it's been around for 11 years, but that's actually not that long in the like grand scheme of things, right? So it depends on what you mean by a DevOps role. To some extent, you need to be able to like write and understand code, but I don't think you need to have spent like multiple years working as a software engineer in order to be like an SRE or a DevOps engineer. You can specialize straight into that. It's more a matter of like understanding the tools that are involved in DevOps. So you're going to write more YAML than you are actual code, frankly. But the Linux Foundation has some DevOps courses occasionally, some like online courses. There's also DevOps for Dummies by Emily Freeman, which is a good read. And that's probably a good place to start, understanding what these tools are and what they do. And from there, you can figure out like specifically in what way do you want to work in DevOps? Like, do you want to work in infrastructure? Do you want to be an SRE? What specialty do you want to go into? Does Artifactory have staging repositories in their free version? You can create as many repositories as you want. And if you want to call one of them staging, you totally can. Similar question, is it easier to move up from software development to DevOps rather than IT operations to DevOps? I don't think so. So like somebody who works as a DevOps engineer is ideally going to be, half dev, half ops. So no, I think they will have the same level of like ease or difficulty in moving over to a DevOps type of role. I wouldn't consider one of them to be more valuable than the other. That's the whole thing about DevOps. It's supposed to be a collaborative culture. So like dev is not better than ops. Ops is not better than dev. We have to work together. We have to be like vaguely familiar with what the other side is doing. So no, I think you're in a good position regardless of which one you're coming from. Have you considered the implications of managing machine learning assets as a part of this suite of problems? Personally, not specifically. So I'm not a machine learning expert. I have like a very, very small amount of experience with machine learning. And frankly, I'm not super qualified to answer whether or not machine learning has implications that would make this problematic in some way. I'm sorry. But if you email me or DM me on Twitter, my contact info is on the slide. I will be happy to reach out to somebody internally at JFrog who has actual experience with machine learning and can answer that question for you. I think I saw somebody raised their hand. Let me back scroll the chat. I see Robin Hood raising their hand. If you have a question, just go ahead and drop it in the chat. Any more questions?
Okay. Well, thank you so much, Kat. It's been a pleasure to have you. And yeah, looks like somebody, yes, there will be a recording of this talk. I dropped the YouTube playlist link in the chat. I'll do that again for folks. But yes, this will be available. And great. Thank you so much. And this wraps up our episode.